So yeah, we'll talk about the unreasonable effectiveness of AI. It's a kind of strange title, but I'll talk about why I chose it in a little bit. So this is a two-part lecture. The first part will be talking about like a background of artificial intelligence in general, and the second part it will be more like hands-on or practical workshop or session showing actually one of like the what I call the wonders of artificial intelligence, which is by the way not ChatGPT, but actually the technology that enabled ChatGPT and enabled machine translation and stuff like this, which is we'll touch upon it in this presentation, but we'll expand on it in the next one, which is what we call word vectors or word embeddings or transformers. So the first like part that I actually want to measure or gauge the how we like have like our sentiment towards artificial intelligence. How do we feel about it? Do we feel positive? We're excited, we're hopeful about it, or do we feel negative? We're afraid and concerned and annoyed, or do we have mixed? Let me try to put this in the chat so that I want to. I don't know how to see the chat here. Let me see. Sorry. Fernando? Oh, yes, here. All right. So let me just put this into the chat. So positive, negative, neutral, or mixed. So I want you to, like, if you're using the chat feature, to just like your position. Where do you stand? Do you feel it's more positive, the effect of artificial intelligence? Is it positive or negative or neutral? And if it's mixed, yeah. So it's kind of Marie Philippe is saying it's kind of neutral. So positive, negative, neutral. Okay, so far it's going more into the neutral side, so mixed or neutral. All right, mixed. Can you just make it into the likes on the three options so that we can see where is it going? So we have more neutral. Okay, negative, positive, neutral. All right, mixed, neutral, and perplexed. Can't find the emoji for that. Okay, yeah. So far it's going. I mean, if you're mixed but towards positive or negative, I'd appreciate that you can put it into the positive into the respective side. So yeah. Um. So far it seems to be completely balanced. We have like 21 people who are, or actually like 23 people who are neutral or mixed, and 3 who are positive, and 3 who are negative, which is great. Now, can you, this is still the interactive part. So can you, if you are like positive or negative, or any of these, really, can you put like your concerns or hopes or like in a sentence or something that about like what do you think the effect of AI will be on us? So that we can see like what are like when it comes to your mind, like the AI, what will how it will affect us? What do you think it will do? So if you can do that. Don't have any responses. It's fine. This whole thing is just like supposedly. Oh, okay, we have here privacy violations, obesity. Interesting, Tracy. Uh-huh. It will revolutionize our lives in the way the internet and mobile telephony have. Very good. Okay. So yeah, it seems this is more to the Francis. Potential for disinformation, how it will be controlled. These are like take the role of labor. Exactly. Yeah. So these are like very like important concerns. Increase the productivity and reduction of posts eventually. That's a reasonable concern. Mixed for me means I'm fascinated about what AI can and will be able to do, and concerned about what it will do to my perception of reality and my profession. Exactly. People might get lazy if AI does the job. Yes. Evolutionary. Yes. It will help reduce human errors. Yes. AI can create ethical issues, job losses, concerns about quality of data into AI. Yes. Also, I heard that lately robots are put to make robots. Yeah, this is an interesting chain of being. When it stops being a tool and becomes an influence, it will make routine tasks easy, but it will make us intellectually lazy and much less autonomous. Can create personalized learning experience, identify students' strengths, weaknesses. This is great. It can also automate administrative tasks in educators. Human skills could be acknowledged less. This is actually great. I mean, all of these concerns, I mean, are much wider than I had in mind. So thank you so much for bringing this perspective. This sounds like an AI answer. AI can help create personalized. Oh, that's Pepe. Thank you, Pepe. Yeah, so yeah, all of these are very reasonable. And let me go back to the, okay. Our brain could get rusty. Yes, 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 yes. So yeah. But I mean, so far, all of these like are actually like very like good perspective, like the whole idea of the survey that we have like this nice normal distribution of people who are like have these balanced views um about AI, and like some people to the side, to the positive side, some people to the negative side, which is actually like a very reasonable distribution. I was hoping, or sorry, I was actually fearing that there would be like a very much like clustering of people to the negative side or something like this. But I think like with better information, you can have like a balanced view of things. So this is actually good. All right. So this interactive exercise was very good. Thank you so much. So let's get back to the presentation. So the idea here is, yeah, we have a balanced view of the effect of AI on us. Now these are basically the concerns that I thought of, which some of them actually come from my science fiction background. I'm a huge science fiction fan. So in many movies and the books, science fiction has portrayed AI agents and robots in either one of two ways, either like an enemy or something bad that will happen to us. Something when you look into like the franchise of the whole Terminator with all of this evil Skynet enterprise that comes from robots, and then you have in the Marvel Cinematic Universe you have Ultron, which also like a very huge enemy to the whole humanity, and the Matrix trilogy, where you have the machines, the things that want to like use us as batteries and like still control us. So it's just like a huge fear of like how if AI gets out of control, it can like overpower us or become our overlord and things like this. And the other way, which is like in other science fiction shows, where you have the AI can be our friend, like in this show Futurama, where Bender can be like this uh, funny and annoying coworker, and also in the Star Wars series, Star Wars universe, where you have C3PO and R2D2 as assistant robots, which also like one of them is like C3PO is like a universal translator. It translates everything, any language. And also in the show that's called Good Place, we have Janet, which is a huge database who knows everything in the world. And then also in the movie Her, which where in which like the AI system is actually become the love interest or the romantic partner of the protagonist of the movie. So it's either like will the AI be good and be our friend, or will it be our enemy? So in the science fiction we have both. Now coming to the point of how it would affect our work, I'm also like have this a mix of like popular culture and reality, because in many cases we will find that the impression is that the automation will replace us, as in like this Tom and Jerry episode where this automatic cat came and replaced Tom, and then um, this is actually a real thing. I've seen it on the social media. Of course, I mean everything on the social media has to be true, but this one actually I've seen it in the upstate somewhere. In a supermarket, you'll find this huge, expensive robot that goes around the supermarket and like patrols everything. And what it does is that if it sees any trash or spills or something need to be refilled in the inventory, it just makes an alarm or alerts the humans to respond to this. And what it does is that basically it brings someone who's working at a minimum wage or something to do basically the janitorial work that needs to be done. So this is not a very nice way of how we see like AI should be doing like the more annoying part of the work. Now, in this case, it is actually doing the interesting part, the supervision part, and then letting us do the less interesting part. And also, one among the many interesting responses, we're talking about how AI will make us lazy and make us dependent and useless. So this was in the movie Wall-E, where it basically humans became exactly like this and just depend on robots to clean up the earth. Um, and then there's this story of John Henry, which I think I've talked about it before, and I've seen it in a book called A Whole New Mind by, I think the author was Daniel Pink. It's talking about the danger of putting like us against the machine in comparison, and by citing the story of John Henry, who's an American folk hero, and he is said to have he has like a steel driving man. He just like um, digs, and then there, at some point, there was this new machine, a steamroller, that was used to like do the same job he was doing. And for some reason, it was decided that there will be a race between John Henry and the machine. And because he's like the best in his profession, he's done a very good job. He did as very good against the machine, and he actually won the race against the machine. But to the detriment that he actually was very tired and exhausted, and he died eventually. So it's just like even it was said in this memorial, John Henry died from a race with the steam drill during construction of the tunnel for the railway company. So this is actually like a very dangerous note that we have to keep in mind, because we should not at any point put like the humans against the machine and they are like competing against each other. This is wrong. So I think we should learn from John Henry's story this point. Now I'm going to talk about AI history. It's just like a very like um, unusual listing of things, but this is like the best way I found it to create a narrative of how AI has started and how it has progressed. It's made of like stories I've heard from Professor Robert Harlick, who was teaching us machine learning at the university, and also from things that I've read in other places. So this is like the main timeline I can think about it, is that it's always started in the 1950s, basically after the end of World War II, where there has this huge significant advances in technology with the invention of like early computers and all of these encryption and decryption tools. And notable in this regard, the work of Alan Turing. You can find it in the movie The Imitation Game, where he was able to to solve one of the mysteries of like the German machine Enigma that used for the encrypted communication. And this led like showed how like his ingenuity as one of the most brilliant people in history. And also later he was the one to try to propose the idea that AI is actually feasible, and he actually put something that is called Turing test, which we'll talk about in a little bit. Also during the 50s, there was this the Cold War. So one of the most important things at that time was to from the American side, of course, they want to achieve supremacy over the Russian and vice versa. So one of the important projects that were there at that time was that the Americans wanted to have machine translation systems that can translate from Russian, mainly from Russian, so that they can keep up with all of like the scientific literature and of course the intelligence work and all of this kind of stuff, because all of this kind of stuff cannot be done simply by humans because of all the amount of material that needs to be done. So a lot of funding has been put into this project, and it was very promising at the time. If I find some of the pictures, they were claiming at that point that it has reached the machine translation has reached a level that is beyond literal translation, because at that point the greatest fear was that the machine translation would be just literal translation, translating one word in Russian to one word in English. So at that point they were saying, yeah, we achieved beyond that. And at that time also, there was this huge enthusiasm just to fund all research in language. So even at that time, you'll find some of the papers by the leading linguists, most notably Noam Chomsky, where he was just starting at that time his brilliant career of as a linguist. And you'll find that in the acknowledgement, he was just acknowledging the funding from the army and the navy to fund his linguistics research. The problem about the work of Chomsky is that, I mean, he is definitely one of the most brilliant people in the history of mankind and of linguistics. But the problem about it is that when he was tasked or when he was asked to do this linguistic research, it was mainly uh, he took it from on his like self as like a way to model or to understand human language as it should be or as it is. So the way he figured, like he developed his theoretical models, he reached what we call universal grammar, which is also called transformational grammar, which is saying that the language in your mind is different from the language that comes from out of your mouth, and there are certain transformations that are involved, among other things. So, but this was problematic in a very important sense here. Why? Because you cannot model this into a computer. You cannot put the same human mind and the same processing into the capability of the computer. And a lot of what Chomsky was saying is that like most of this language faculty is innate. It's already there in your mind. And he didn't give like a model that you can like give the computer something and it will give you something. He actually criticized these models and still does. So he did not help like advance this part of using linguistics as a way to model human language in a way that can help computer and help artificial intelligence in language progress. So from this point onward, they went into separate directions, like the linguistics, in terms at least of Chomsky's school of thought, and artificial intelligence when it comes to language. They went into separate directions. There are some overlaps at some point, but yeah, but this was, I think, was a major milestone, which I feel like when I look back at it, it feels like it shouldn't have been really this way. But anyway, among other things, also during that time in the 50s, all of these things were happening at the same time. So one of the interesting stories that was I heard from Professor Harlick was that also like the biggest motivation for artificial intelligence is actually to gain some military advantage. So one of the biggest issues that the US was facing at that time was how to spot or identify the locations of Russian submarines, because there are two big huge oceans, the Atlantic Ocean and the Pacific Ocean, and the US wanted to find a reliable way to know where each Russian submarine is, given like the basic readings of the sonar, which you cannot put sonar everywhere in the ocean. So one of the interesting projects at that time was that the US asked, or the US generals, the military asked one of the research institutes I'm not exactly sure, was it MIT or Harvard or something like this, but it's one of the institutes that had like very reputable faculty or experts in statistics and in engineering and in early computer science, of course, to create a system to model the distribution of Russian submarines given um, given the sonar recordings or readings. So this is um, uh, an interesting task. So the professors just asked, okay, so give us the data that you have, like all the data, the sonar readings and the sightings and all of this kind of stuff, and tell us, and then we will create a model for you. So the professors or like the experts worked on the data, and after a while, they came back to the Pentagon people or to the military people and told them, yeah, here is a model that can predict the location, the existence of a Russian submarine with like 90% or 95% accuracy or something like this. This was brilliant. And everyone was happy with this, except for the fact that when they actually put it into practice, you'll find that the system, in many cases, it predicted that there's a submarine, but there's no submarine at that time. And then another, in many other cases, it would, if there is an actual submarine and it wouldn't detect it. So at the end of the day, they figured out that the system is practically useless. But this led to one of the most important concepts of machine learning and artificial intelligence and learning from the data in general, which is what they call the holdout method, which is basically this. If you are trying to learn from the data, from the statistics of the data, then you cannot just learn on the whole data and then try to apply on that, but you have to split the data into like training data, like the data that you use to build your models, and then training, and then testing and development data, where you can test the model if the model is actually accurate or not, because now you're testing it on a data that it has not seen in the training. You'll find the significance of this when we talk about like ChatGPT and things like this, because the whole idea of many of these systems is to learn from existing data. So if you, in order to make sure that you're actually doing the right thing, is to have a data that the system has not seen before and see if it can handle it well or not. So so now we are still in the 50s. So now we have all of this promising things about machine translation and promising things about the initiation of machine learning. And we have the Turing test that sets at least some kind of a goalpost where we see that are we able to achieve this so that we can say that the machine is thinking or not. But then very soon, yeah, there has been some counter things, and we'll talk about like the Turing test in a little bit. But for the machine translation and machine learning in general, machine translation, I think in particular, the US government has seen like there has so much spending on this, and there is no actual result, especially now with the like inputs of people like Chomsky were saying like, yeah, you cannot model language like this. So it became we reached some kind of a level of like disillusionment, like now it doesn't seem that it will work, and it doesn't give us any reasonable results and all of this. So there was in the 60s there was what is called the ALPAC report, which is a report also by the US government to check to audit the funding of all of these artificial intelligence projects and mainly the machine translation. And then they figured out to say it's not doing anything. It will just be more reasonable just to spend all this money on doing like automated dictionaries and translation support systems, like probably cat tools and stuff like this. So this was the main outcome, and it led directly to what we call the AI winter, where no one wanted to work on AI anymore because there's no funding anymore. Um, so yeah, this was one of the things. And then also at that time, there was this interesting work on machine learning by a brilliant researcher called Rosenblatt. Not, I don't remember exactly his first name. And he was working on something called connectedness, which we came to learn later as neural networks. So this was in the 1960s, I believe. and it was working like it was seemingly very promising in terms that this neural networks is able to model any mathematical function, and even like we have all of these complexity and variation and all of this kind of stuff. So neural networks can handle this, and it was like supposedly one of the promising technologies in this area. The problem is that we are talking about like human beings, so some of the issues that has happened is that like there is like these human friction and this jealousy and judgment and between people. So the leading people in machine in artificial intelligence did not like Rosenblatt, and they treated him very harshly. And I think one of the major people in this field was, his name is Minsky. He wrote a whole book just to refute the idea that neural networks can be a useful technology, and it actually led to like stopping this whole thing. And very soon enough, Rosenblatt passed away in a boat accident, and his research enterprise did not continue. So now we're talking about 1960s, and then all of this kind of stuff stopped. But now in the 1970s, there is still a little bit of renewed interest in machine translation and in other artificial intelligence systems. And also, like the military started again doing these, what they call, I think, DARPA challenges, which is some kind of like challenges or tasks that are asking researchers to work on. So one of these, so of course, there has been this start of now the companies are starting to actually get into the field of machine translation. I think Sistran was founded at that time. I'm not exactly sure about the timeline. And also there was this these DARPA challenges where the Pentagon people would ask researchers to work on, for example, classifying text or extracting certain information from text and things like this. So again, this was one of the stories of Professor Haralick, where he was telling us about these challenges. And it was interesting because like the demographics of the academics there were kind of like, it was still kind of like the linguists have been present, like people like Chomsky and his, of course, other linguists, people like specializing in linguistics. They were still like being invited to these challenges. And um, according to Professor Harlick, he was just saying like these people are just brilliant. They would just come up with like the best models and like very intricate and very smart models. But the problem is that, yeah, all of these models looked very nice, but they didn't really solve the problem in a reliable way. And then one of the people who were coming, like, I think from electrical engineering or from early computer science, was saying that, for example, for the task of classifying text, okay, so do we have to understand all the texts? Do we have to like know that this sentence is built of these words and these words are related in such a way? Or we can just like have the text and put it all, like all the words, and then dump all the words together. And then then he created something that is called a bag of words. Bag of words is just like one of the methods in processing language, where you can just take all the words together and dump it into the computer, and then the computer would do something about it. And it seems that this approach has actually like started to yield results, because now we can see like, okay, now we can classify things in a reasonable way, because you find that in this text there's this word and this word and this word. So it will, this is politics, this is sports, this is whatever. And now you can have like a reliable way to classify the text. So this again, one of the nails into the coffin of how linguistics contributed to artificial intelligence now, because like it's basically like just like computer programming or just like counting things. So it doesn't, so we don't need any linguistic knowledge in this regard at all, unfortunately. And also another one was at that time was that like with Sistran and new systems for machine translation, they're also trying to employ linguists to help with the modeling of the language and all of this kind of stuff. But then at some point also there was this famous quote, which I do not remember who was the author of it. It was that one of the major like leaders of these companies was saying that, okay, we used linguists to help us with machine translation work, but then it was just they're not helping. So now whenever I fire a linguist, my performance goes up by 1%. So it was interesting. And of course, I mean, it's sad for me as a linguist, but it was actually the sad truth was that, yeah, actually, you don't need linguistic knowledge to actually process the language. You can just need like some solid computer programming for that. So yeah, so this is so now at the 70s we reached this point, and then in the 80s there was the start of like personal computers, and like the whole idea of like the computational power is becoming better. Now we have like a new revival of neural networks. Some people, I think it was Jeffrey Hinton, he started to look into neural networks again and say, okay, this is a good approach. Why didn't we use it? And then with the new computing power, say, okay, now we can apply it to like things like image classification and things like this, and it worked brilliantly. Now you say like, oh, I think this is actually a good idea. And now there was a new also renewed interest in machine translation, but now the machine translation that is used now they're calling statistical machine translation, which is actually a machine translation system that does not need any knowledge of the language. It's basically you process the language as phrases, as words, and then you see like this word in English matches this word in French, and this phrase in English matches this phrase in French, and then you put it together and you create some kind of Frankenstein sentence. But in many cases, it can be useful, especially if you're like have like a very standard phrasing of your language, and then it works. So this was the early times that neural networks are having a comeback, and statistical machine translation is actually being implemented. And this was like in the 80s, in the 90s. So I mean, the boundaries are not that like bounded by the year itself or the decade itself, but it's just like around that time. And around that time also, I don't think I included here, but there was also these huge interest on having like a huge system that can actually understand the world. Because one of the things that they were just saying at that time, that the AI cannot process the language, or because it does not have a world understanding. So we need to tell it that like these basic facts, like a human person has a head, and we walk on the earth, and all of this kind of stuff, which is like um, you have to like give it like considerable amount of facts in this regard. So one of the projects at that time is called SICK, like which is short of encyclopedia, which was just that, try to encode all of the real world information just to give it to the computer. And this was I think in the 80s and maybe in the 90s, but I think it stopped. Maybe you can look it up, but I think it stopped like short enough, because I mean you cannot really compile every word or like every fact in the world just to put it into the computer, let alone process all of this. So at that time, you see like things are coming back, and then there are efforts um, to introduce new things. But then in the 2000s, um, yeah, in the 2000 and 2010s, we'll find that things are starting to get more like institutionalized. So we have the idea of like machine learning and statistical machine learning and all of this kind of stuff. And natural language processing was like it's part of um, the way that we process language as an academic field. And there has been this what they call shared tasks, where they can like share tasks for like identifying named entities, like the names of cities in the text, or the names of countries, or the names of people. So we find that all of this work has been going on in the 2010s. And then in the 2010s, there are actually like one of the most huge, or the biggest milestones, where in terms of processing language, where there in 2010 the idea of word vectors was introduced. I cannot really overstress the importance of this technology. That's why I mean there's a whole lecture dedicated to it next time, because it's basically solved the problem that how can you get the computer to process language is just basically by turning words into numbers. Now computers are good at processing numbers, so now it can do it much better. And now also the idea that we now have neural networks, so neural networks can take these numbers and do something with it. And the whole idea of word vectors, they are also some kind of neural networks themselves. So we find that everything eventually converges and connects. So now when we have neural networks and we have word vectors, now we can start to put them into a more advanced machine learning and machine translation. Now we have the neural machine translation system by Google in 2015 with all of the iterations and all of the different systems by Microsoft and DeepL and all of this kind of stuff. And recently, um, and afterwards, there also Google improved on the whole idea of word vectors by introducing something called the transformer, which is like a way more complicated way of describing language in context and with showing the positions of words and things like this. And this transformer was actually the thing that was used in GPT systems by OpenAI, and GPT system were the basis of ChatGPT, which is the whole hype is going on about nowadays. So this is where we are right now. So this is basically my like huge, like very long rant about the history of artificial intelligence till this day. There are different ways of having, like, if you can see like my slide, you'll find that there are different timelines of artificial intelligence. You can look at that. But I think I'll take this opportunity to take a little break so that we can take some questions and do some discussion before I move to the next part of the lecture. Sure. So okay, so now we have this timeline. Okay, so one of the things that I wanted to talk about is this Turing test, because many people were just saying like, is artificial intelligence like aware, or is it thinking, or did it reach the human intelligence? So this was like one of the early things in the history of artificial intelligence, where Alan Turing was proposing that if a machine can carry out a conversation over like a teleprinter or a chat or something that was indistinguishable from a conversation with a human being, then it's reasonable to say that the machine was thinking or that it is intelligent. So basically, if you have like a covered closet and you don't know what is coming from out of it, was it the machine or a human, then it means that this actually a machine is intelligent. However, I mean, till this day, I find that people saying like, oh, that Chat GPT is just like they defeated the Turing test and things like this. But the interesting thing is that as early as, I think it was still 1950s or 1960s, I think 1960s, 1964, there was this system that's called ELIZA, which, but even with these early computers, it would just simulate a communication between a human and computer, and it would just pose as like what they call like a psychologist, who was just like, whenever you ask him a question or tell him something, he would respond to you in a way that seems that he understood the question, rephrased it, and then tried to get you to talking. So many people were fooled to think that this is actually a human responding to them. So as early as 1964, it seems that this Turing test was broken and or achieved at least. And now we don't have like a very standardized way to say like at what level is the machine. Have we reached what they call artificial general intelligence, or like AGI? So have we reached it or not? So this is the thing. And if you want to actually to experiment with this, Eliza, it's in this link there. So maybe I can put it in the chat so you can see how it works. That one of the implementation of ELIZA. And now I will be talking about three milestone papers that I think can capture most of the essence of the progress of artificial intelligence when it comes to language. So the first one is what's called the unreasonable effectiveness of data, which is how I actually like the plagiarized it to for my own for title of this lecture, the unreasonable effectiveness of data. It was by Google, and there is this paper which is called efficient estimation of word representations in vector space, which is a very like complex way of saying that this paper about word vectors. And then this paper, which also has this interesting name, says attention is all you need. which is also introducing the idea of transformer, which is like an advanced way of word embeddings. All right, so we'll talk about these. So the first one is the unreasonable effectiveness of data. It was in 2008. So let me read from it because it's very interesting, at least this introduction. Because actually there are like uh, Eugene Wigner's article titled "The Unreasonable Effectiveness of Mathematics in Natural Sciences" examines why so much of physics can be neatly explained with simple mathematical formulas such as F is equal to ma or E equals mc squared. So it seems that they also copied this idea of unreasonable efficiency effectiveness of this. And so yeah, it's and actually like when you look into the literature of artificial intelligence, you find that the unreasonable effectiveness of X is very prevalent. So yeah, I'm not the first one to use it here. So this is actually like a very interesting idea because I mean, yeah, how come is nature like follows all of these nice formulas? F force is equal to mass times acceleration or Einstein's formula. But it seems that it does. So meanwhile, sciences that involve human beings, so they're talking about that things like economics does not cannot represent things like this neatly, and also language because they're saying that in order to represent the grammar of English, you need like 1700 pages. I slightly disagree. But anyway, perhaps when it comes to natural language processing and related fields, we're doomed to complex theories that will never have the elegance of physics equations. Again, like wink, wink, back to like Chomsky work and linguistics work. But if that's so, we should stop acting as if our goal is to author extremely elegant theories and instead embrace complexity and make use of the best ally we have, the unreasonable effectiveness of data. So this is how they introduced the idea. And now this is one paragraph also. So they're talking about these researchers show how a relational logic and a 100 million page corpus can answer questions such as what vegetables help prevent osteoporosis by isolating and combining the relational assertions that kale is high in calcium and calcium helps prevent osteoporosis. Again, this is something that we might find very interesting, for example, in ChatGPT, when they're like, it seems it has some world knowledge, it knows this relates to that. So the whole idea that they're trying to say here that unreasonable effectiveness is that when you have so much text, you'll find so many of these patterns on so many of these assertions that you can combine together and try to make sense of things. So now you can say like kale is something and osteoporosis is something and calcium is something. So now you can actually answer questions, what vegetables help prevent osteoporosis? By just giving a huge corpus of data of text, then the computer will be able to figure out things. So, and this was like they were talking about other aspects, but now for the next paper, it's basically talking about word representations. It's again by Google, so it seems that much of this interesting work has been done by Google, and it's basically how to represent words as vectors. So it's called word vectors, and sometimes it's called word2vec, or sometimes called word embeddings. And the whole idea is that you're representing words as numbers. So when you represent them as numbers, then you can see the relationships between them. For example, you can see that the relationship between man and woman is the same or similar or parallel vector to the relationship between king and queen. So we can identify that part of the meaning of this word involves male and part involves female, things like that. And then you'll find it in verbs. And then you can even find it between like the relationship between a country and the capital. Like Ankara is the capital of Turkey, Ottawa, Canada. So you find all of these just by giving the computer a big lump of text, and then it will see, the relationships hold. I will be talking more in depth about this next lecture because this like, the whole idea of how it got there it's very interesting. And then you'll find the relationship between France and Paris. You find okay, so find all of these relationship between words just by feeding it some text. And then you have how to explain this. I mean, not anyone has a real answer. Why does this produce good word representations? Good question. We don't really know. And then, but the idea that similar contexts have similar meanings. We don't have like a clear way of describing it. But yeah, if you put the word in a similar context, probably it has a similar meaning to the other one. Yeah. And then you have this paper that came in 2017, and then it's called Attention is All You Need. You'll find that the names of these papers are very interesting. And then afterwards, they have like a huge amount of papers, just like this is all you need. Attention. So you find that all of this also is used a lot. And it's basically introducing what we know as transformers, which I will not go into detail, and even I'm not exactly sure if I understand everything about it, but it's just like a more elaborate way of uh, putting your word embeddings into like a better use. And then this is what they call about when they talk about attention. Attention here is what they call here. I mean, sorry, I didn't find a way to revolve this. So it's basically you are trying to find a word, and then you see which words are related to it. So you pay like for that, the neural network would pay more attention to these. And now we're going back to like we're going to where we are in the cutting edge applications. So I'm not going to talk about this in any sort of detail because it's just like very complicated. So neural machine translation, it's um, it's basically representing words as a sequence of words, and then which is actually translated into a sequence of vectors or sequence of transformers, and then you feed it into a neural network, and then the neural network will give you a sequence. So that's why they call it like sequence to sequence translation. Sequence of words goes to sequence of outputs, and then it will just give you the output. And because these transformers identify these relationships between words, you'll find that it is now better at making sure that the words have a proper equivalent and they are in the proper order. And in general, the results are usually good, at least much better than the previous machine translations we had. And then we have the big guest here, the ChatGPT, which is a very interesting project by OpenAI, and it just represents um, a very advanced chatbot that you give it questions or give it some input, and it will process it and give it up. The issue is that I'm also not going into detail about it because it can be very complex. The whole thing about this, the G part of it, is called generative. Generative, it means it generates text. And T here is the transformer. I forgot what P is. So it's basically a transformer that is used to generate text. How does it generate text? Something like this. For example, you have a sentence like, the best thing about AI is its ability to learn or predict or make or understand or do. And then you find a percentage here for each of these. This percentage can depend on many things, like how usually this word comes after this sentence, or how this sentence is supposed to talk about certain topic, things like that. And then you'll find that it goes on generating things like this. The best thing about AI is ability to, and then create, and then check what are the next word, create worlds that are both exciting and so on. So I find that it is like when you like think about it, it's more like the text prediction that you have in your phone. You type a word, and then the phone gives you suggestions about these like three possible words that come after this, and then you click on one. And some people actually do some games about it, like you just keep generating the next word, the next word, the next word. So it's just like that, and like in the very basic sense, but with all like the data, given that like what OpenAI is doing is that it's feeding the whole internet, basically like all the blog posts and the internet websites and poems and ebooks and all of this kind of stuff, feeding it into the machine. And the same as we have seen in the article, the unreasonable effectiveness of data is that, yeah, if you put it all of these together, then you will start to see like the patterns between things. And also when you put it like this, as we have seen also in the paper, like about the word vectors, is that you find that each word has its vector, and then you know that these words are related together, and then you start to see how things are connected to each other. And now you can, when you are writing something, you know that what are you writing about. And it's I mean it's I don't see it's that difficult if you think of it this way, but it's definitely a huge undertaking, especially if we're talking about the whole information or the whole data on the internet, or I'm not exactly sure because OpenAI is not very open about this. They do not tell you exactly what data is trained on. But then again, we'll come back to the point that I was talking about when we were talking about the Russian submarines, is that it like the ChatGPT is given so much data of the internet, but you don't know really what data is it fed on and which data is it not. So you find that in some cases where the data where you're asking about something that it has not seen before, then it will it start what they call hallucinate. It just generates very random answers about like some ask about a person that does not exist, and then he starts to say this person was born this and this and this, and then giving you his publications and this kind of stuff and stuff. So a lot of this, it doesn't make sense. It's just like happens that because it has so much data and not a real sense of the word and not a real way to say like this data belongs to what it has been trained on and what has not been trained on, then you'll find that it's a mess. Okay. So now we have come to the conclusion. I mean, of course, I'd love to talk more about ChatGPT, but it's thank you, Francis, pre-trained. So GPT is generative pre-trained transformer. Thank you. And I'll be finishing like in a few minutes the conclusion, then we'll talk about the question. Thank you. So the main conclusion is that AI has not reached, or not yet. I mean, I have this question mark, so I'm not exactly sure about it. Will it ever reach or not? It has not reached human level intelligence, but it can do some tasks that previously were thought only humans can do. Like, for example, answering questions and finding this kind of information. Even things like Google and things like this, a lot of it is supposedly it was unimaginable before. But now we have AI doing so many of these things. It's just sometimes they call that there's a AI definition problem, where sometimes when a problem that was supposed to be an AI problem, it is solved, and then they say, no, it's not no longer AI. So this actually, you find this in the literature. And then you find that modern AI solutions do not process language as humans do, which is, again, I blame this on the lack of linguistics, the involvement of linguists in the development of these systems. And there is an over-reliance on massive data and computation rather than actual language understanding. Again, this is the idea that, yeah, I mean, the computer does not process each sentence individually, but it builds on all of like billions of data that it was trained on, so that it can say like tentatively what the sentence means or what are the elements in it. Also one important thing is that most modern AI solutions are black box. You do not really know what is in there. It's a neural network that you give it, like feed it some transformers, and it gives you an output. You really don't understand what's happening and why did it come with this. If I give you an answer for ChatGPT, for example, it wouldn't know that this answer because it came from this article in 1972, which has this like URL in the internet. No, it doesn't give you that. It just lumps everything together and gives you an answer. So this is problematic because, for example, you want to debug, you want to say like it has some kind of a racist or like a biased opinion. Can we just remove this from our data? No, we cannot. Um, and also, modern AI solutions are dependent on the data they are trained on. Again, if you are training it on like literature, it will give you like literature output. If you give it to write in technology, then it gives you technology output. The problem is that if you are just feeding it everything, when it doesn't really yeah, I mean, it's just not clear what to expect. Of course, you can tell it like give me an output that is scientific or give me an output that is literally or legal or something. It does this, but it's not very clean or not clear cut. So again, when we're talking about like it's important to work on the data, to curate appropriate data, identify the data in each application. So again, when you have, for example, translating legal, then probably you need to have legal data. When you're translating scientific, you have scientific data. So the idea of data curation and data selection, it's a big thing and it needs to be properly understood. Then there is a point about policy and business conclusions, because what I understand is that we need to do something about like the progress and development of AI, both as like creators, we are like creating the data that is used for AI, and as like in terms of like the researchers and decision makers and the investors and all of this kind of stuff, we need to help the AI to progress into the direction that would help us, help everyone. So the things that I think are more important here is that more research should be directed to explainable AI. This is a whole area like when you're like AI gives you an answer or output to something, like an output, you're giving it a sentence, and you're giving it a sentence to translate, and it gives you a translation. Then I will need to see how did it come with this translation, from which documents did it bring this, and things like this. And also when it goes like ChatGPT, you ask the question and gives you an answer, how did it come with this answer, and things like this. And even for things like even for example in for doctors and diagnostics and stuff like this, you cannot say like give it to the computer like the readings of the patient, and then the computer say like this is like has this kind of disease or not, without telling you on what basis did it make these diagnostics, because it has these measurements and these symptoms and all of this kind of stuff. So this is why we still like human doctors are important, so that you can know like I said that this diagnosis is this person is sick of this disease because of these this and this symptoms and this laboratory reports. So this is important here. And then we'll have, I think it's also important to focus on small scale models for certain tasks. For example, when you're like working on like Facebook or Twitter or something like this, I cannot really put a whole the internet in something like ChatGPT just to see like this this post is offensive or not, or does it have hate speech or not, and things like this. So we have to have small, or when you're looking like processing the whole documents of the United Nations, I will not like give each document to the Chat GPT so that you can extract the information that I want. I want simpler systems that can help me with this. And also to leverage AI to enhance human learning, so that we can say, like I think it was suggested in by some of you here, is just to make sure that the AI is put in a way that we can use it to learn actually, rather than it just learns few things and we don't know exactly what it knows, and then we are expected to correct it or something. But it should be human learning in addition to machine learning. Also, to use AI, it's very important that this is the best, our best ally to combat hate speech and false information. If we put it right, we can do a lot of good work just to detect this is hate speech, this might have bad consequences, or this is false information, this kind of stuff. So we need this. This is one of the top areas I think AI should be directed to. And also, AI systems should be designed to augment human performance in jobs, not replace them. Again, this is one we'll talk about, like translation and diagnostics and writing reports, all of this kind of stuff. You need to, you do not just give us an out, you don't want the AI to just to give us an output, a black box output, but to give us a process, like a steps of how and reasoning of how it reached this. So this is something that if we have it, then our performance will be augmented significantly. And then we also need to keep analyzing our different aspects of work, because now we're talking about translators. Then we see like what areas of translation can we just give it to the machine and don't even think about it, because I mean we have lots of like templates and things that are like immediately can be translatable if you just give it to the machine. You don't even have to think about that. So this is part of like job redesign so that we can adapt to the technology. And then also we need to like analyze the shortcomings of and the limitations of different AI solutions. Um, so yeah, so this is like, I mean, of course, there's like a lot of fascination with ChatGPT and machine translation, but it's very important also to look into like to have be like red teaming and devil's advocate to see like where does it fail, what does it get wrong, where does it like mess things up. So I think this is very important to have like a careful analysis of this. And then I will finish with this kind of mystic note. It's I think it's a thought that I have always it always comes to my mind whenever I like use machine translation and find like a brilliant translation of an expression or a phrase or a word. So you know, wow, the human, the human, the actual human who translated this before, and then the machine brought this translation to me is brilliant. So I say like the creator of this elegant output is like that. So the elegance of the creation is from the elegance of the creator, and we are in a way, in a sense, the creators of these systems, whether machine translation or ChatGPT. It's all based on the bulk of human knowledge that we have created over the years. So this poem that I found in like at some point, it's very common that this theme is very recurrent in the Sufism and mysticism in Islam, which is like when some people or some poets, some Sufi mystics, they will say like, whenever I see a beautiful face, I recognize that it is the beauty of the Creator. So it's here like وإذا نظمت تغزلا في صورة فلأجل حسنكم المحجب أنظمه. So this is by a mystic called Najm al-Din ibn Israel. He say, whenever I compose a love poem admiring the image of someone, it is for your hidden beauty of the creator of this beauty that I compose it. So it is just for us that we are the creators of this, and this is something that we appreciate to everyone who contributed to that. So thank you.